Hi, in this video we are going to learn about generation of BPSK, that is binary phase shift keying signals. It is Sridevi, Professor, Department of Electronics and Communication Engineering. So on completion of this module, the learners can be able to understand the concepts of generation and detection of binary phase shift keyings. Generation is happening in the transmitter side and detection is happening in the receiver side. Basically, the principle behind BPSK is binary phase shift keying. The binary symbol 1 and 0 modulate the phase of the carrier. Let A represents the amplitude of the signal carrier, and S of t is the signal, that is A cos 2 pi F naught of t is the one signal, and 0 represents another signal. So 1 is represented by the signal which is having phase shift, and 0 is represented by the signal which is having no phase. So simply B of t can be represented as plus or minus 1, and 1 is nothing but plus 1 is nothing but whenever the symbol 1 is transmitted, and minus 1 is represented by as whenever the symbol 0 is transmitted. This is also called as two-phase BPSK or phase reversal keying. So this is simply the technique whenever the sine wave carrier takes the phase levels in between 0 and 180. So BPSK, that is simply double sideband suppressed carrier modulation scheme for message being digital information, having digital information. The generation of BPSK signal consists of the data sequence, bipolar NRZ encoder, and balance modulator, followed by the carrier signal, and finally BPSK signal. So to generate BPSK signal, we built on the fact that BPSK signal is the special case of double sideband suppressed carrier modulation. So BPSK signal can be generated by applying carrier signal to the balance modulator. So non-return to zero level encoder. So simply it is whereby the input binary data sequence is encoder in polar form with symbols zeros and ones represented by the constant amplitude. So there is one product modulator or balance modulator can be used, which is multiplies the input level and encoded binary wave by the sinusoidal carrier of the amplitude to produce the BPSK signal. We are using some timing pulses which is used as the carrier signal, so that the message and carrier signals can produce the modulated signal by BPSK signal. So BPSK signal that can be represented as two levels B of t for positive and B of t as negative. So the transmitter is simply represented as binary data input, level converter, and balance modulator, band pass filter, and modulated PSK output. So balance modulator, one of the another input is sine omega ct, that is one signal, and another the pulse signal. So here the waveform is generated after passing these blocks, and finally BPSK signal is generated. So the signal which is received having the phase shift as 0 and 180, this signal undergoes to the phase change depending upon the time delay from the time transmitter to the receiver. So as a result, the signal having the phase shift as 0 or 180 degree. Whenever 0 is there, that represents logic 1, and whenever 180 degree is there, that represents logic 0. So the application of BPSK is, it is simply used in CDMA, code division multiplexes, WiMAX, that is in standard 16D and 16E, wireless LAN 11A, 11B, 11G, 11N, and satellite, DVB, cable modem, etc. Simply, and it is also used in most robust among all modulation types due to difference of 180 degree phase shift between the consultation points. So we have one quiz question based upon BPSK. So simply the binary phase shift keying system, the binary symbols 1 and 0 are represented by carrier with phase shift of, we have four options always, for 0 and 180 degree we have learned. So the phase shift is in between 0 and 180 degrees pi. So having the phase shift of 5. So always in BPSK signal, the binary zeros and ones are represented with the phase shift of pi. Thank you.